Ever felt like you're shouting into a void, with no idea if anyone's listening? That's what managing a massive telecom network used to be like. Imagine thousands of devices, routers, switches, servers all humming away, or worse, silently failing. It was a digital dark age. Technicians were flying blind, reacting to problems only after they caused major outages. This was the era of guesswork, of frantic phone calls, and of frustrated customers. But then, a quiet revolution happened, and its name was SNMP. SNMP stands for Simple Network Management Protocol. Now, simple might be the most misleading word in all of tech, but its impact. Anything but. SNMP was the light switch that illuminated the entire network. It allowed, for the first time, a centralized system to talk to every single device, to ask it, "How are you doing?" and actually get a clear, standardized answer. Think of it as a universal translator for network hardware. Before SNMP, every manufacturer's equipment spoke a different language. It was chaos. SNMP created a common ground, a lingua franca that everything could understand. This wasn't just an upgrade, it was a fundamental shift in how we see and control our digital world. So how does this magic work? Let's break it down. At the heart of the system is the SNMP manager. This is your command center, the big boss. It's a piece of software, often running on a powerful server, that oversees the entire network. Then, on every network device, your router, your switch, that server in the corner, there's a little piece of software called an SNMP agent. The agent is like a built-in spy or a health monitor. It constantly keeps tabs on the device's status, its CPU load, memory usage, temperature, the amount of traffic passing through its ports, you name it. The agent stores all this information in a highly organized database called the Management Information Base, or MIB. The MIB is like the device's personal medical chart. It has a hierarchical tree structure, where every single piece of data has a unique address, a unique object identifier, or OID. For example, there's a specific OID for system uptime, another for the traffic on Ethernet port number 3, and another for the fan speed. It's incredibly detailed. Now, the SNMP manager can do two main things. First, it can proactively pull the agents. This is called an SNMP GET request. But what if something goes wrong between polls? What if a critical server suddenly overheats? Waiting for the next GET request might be too late. That's where the second key function comes in, SNMP traps. The agent is configured with certain thresholds. For instance, if the CPU temperature exceeds 80 degrees Celsius, or if a critical network link goes down, the agent doesn't wait to be asked. It immediately sends an alert message, a trap, directly to the manager. This is the breaking news alert. The manager receives this trap, and boom, an alarm goes off, an email is sent to the on-call engineer, or a ticket is automatically created in the help desk system. This transforms network management from a reactive, firefighting mode to a proactive, problem prevention model. We're not waiting for customers to call and complain that the internet is down. We know about the failing component before it even causes a widespread outage. This visibility is a game changer for telecom companies. Their networks are sprawling, complex beasts. Before SNMP, finding the root cause of an issue was like searching for a needle in a haystack, in the dark. A slow internet connection for a whole neighborhood could be caused by anything from a faulty fiber optic cable miles away to an overloaded router in a central office. Technicians would have to manually check devices one by one. It was slow, inefficient, and expensive. With SNMP, the picture is crystal clear. The monitoring system might show a spike in error packets on a specific switch port. Instantly, the operator knows exactly where to look. This ability to pinpoint faults with surgical precision reduces downtime dramatically. And in the telecom world, downtime is a killer. It means lost revenue, unhappy customers, and damage to the brand's reputation. Let's think about capacity planning. How does a telecom provider know when to upgrade its infrastructure? Do they just wait until everything grinds to a halt? Of course not. They use the historical data collected by SNMP. By analyzing traffic trends over weeks, months, and even years, they can see which parts of the network are approaching their limits. They can see that data usage in a particular suburb is growing by 20% every quarter. This allows them to proactively schedule upgrades, adding more bandwidth or more powerful hardware long before performance starts to degrade. This is data-driven decision-making at its finest, all powered by the humble SNMP. It ensures a smooth, reliable service for you and me, the end users. Security is another huge benefit. SNMP can monitor for unusual activity. A sudden, massive spike in traffic to a specific server. That could be a distributed denial of service, or DDoS, attack. The SNMP trap can provide the first warning, allowing security teams to mitigate the attack before it takes the service offline. It can also track login attempts, configuration changes, and other security-relevant events. By logging who changed what and when, SNMP provides an essential audit trail, which is crucial for compliance and for investigating any security incidents. It turns the network from a black box into a glass house where every action is visible. Over the years, SNMP has evolved. We started with SNMP v1, which was revolutionary but had some major security flaws. The data was sent in plain text, which was a huge risk. Then came SNMP 2, which made some improvements in performance but still had security weaknesses. The real leap forward was SNMP v3. This version introduced strong authentication and encryption. Now, when a manager talks to an agent, it's not just an open conversation. They first verify each other's identity, and then they encrypt the entire conversation. This means no one can eavesdrop on the management data, and no malicious actor can send fake commands to disrupt the network. For a critical infrastructure like a telecom network, this level of security is non-negotiable. SNMP 3 made the protocol robust and trustworthy for the modern era. So, from a state of total darkness, where network problems were mysterious and crippling, SNMP brought us into an age of light and visibility. It allows telecom operators to see everything, understand everything, and control everything. It helps them fix problems faster, plan for the future smarter, and keep the network secure. It's one of those foundational technologies that you never see, but that you rely on every single time you make a call, send a text, or watch a video on your phone. It's the silent guardian, the watchful protector of our hyper-connected world. It turned chaos into order and transformed the art of network management from guesswork into a precise science. Next time your internet connection is flawlessly fast, or your video call is crystal clear, take a moment to appreciate the invisible workhorse chugging away behind the scenes. That's the power of SNMP, the unsung hero that brought our digital infrastructure out of the dark. Thanks for watching, and if you found this journey into the heart of network technology interesting, don't forget to like, subscribe, and hit that notification bell for more deep dives into the tech that powers our world. See you in the next one.